Good afternoon, everyone, and I'd like to welcome you all to the fourth webinar from the MSpot Cycle 1 Vale edition. Here we are again with another one of our webinars in order to explain to you all the challenges involved and displayed here by Vale. We already had a couple of those. We're heading now to the middle of our webinar sections, and today we're going to talk about a couple of areas. So let's start this. To introduce myself, my name is Guilherme Marinho. I'm sure who's been following this webinar sessions in English has already know me, has seen my hair grow quite a bit. I'm a corporate accelerator for Neo Ventures, and we are here together with Vale, offering these challenges in the hope that we can get some really nice solutions to all of the actions involved in the Vale areas inside MSpot. So just a quick overview as I am talking with you guys in all of those sessions about MSpot. MSpot is a customized program to solve the exclusive challenges of the mining hub, mining companies, and the associated suppliers. Inside MSpot, the mining company or supplier can launch a specific challenges and of its exclusive interests according to the operational or strategic need of that company. So what MSpot allows is for the mining company inside Mining Hub to work on challenges that are exclusively linked to their action and to their day-to-day operations, so that they can feed innovation hubs faster and solve challenges that they really feel are exclusively linked to their needs. This first cycle will be conducted by the mining company Vale, and we will follow the following schedule. We are working on MSpot Cycle 1 since late April, from the setup stage where we got to select all of the challenges that are now being worked. We had our program launch during Mining Hub's demo day on early June or June 3rd. And we are now in the middle of our disclosure and application section, where we are receiving all the applications and disclosing all of the challenges so that you guys can understand what is it that's being offered and how you guys can apply. So if you follow us, we're conducting webinars every single Tuesday and every single Wednesday at 2 p.m. on Brazil time. Follow us always on this channel, on Mining Hub's YouTube channel, to get all the information on MSpot. We're going to conduct a startup selection stage after our deadline for applications, which is important to stress, is on August 9th. And after that, we're going to run a startup selection stage with interviews, a bootcamp stage, which should last around 5 weeks. And after that, we'll start the proof of concept execution, which will happen probably in later this year, all the way to early 2021, finishing in early March 2021. All of this information is already linked in Mining Hub's website, so you guys can check this out and see it for yourselves. Also, you will find there the call for applications, and you will also find the link to apply to MSpot Cycle 1. So with no further ado, let's talk about our challenges proposed for today. So this webinar is kind of special as we are dealing with a couple of different areas. We'll start with geotechnics. And as I've been saying for the past webinars, these are all of our 7 areas that are being worked on MSpot Cycle 1. And today we're talking about geotechnics, as I mentioned, and technical marketing. As I also mentioned earlier, you can find all of this information on the Mining Hub website, which you can access through the link below. And you'll find there the link directly to the MSpot program, where you will find our call for applications and also our link to apply your solution. So for the Geotechnics Challenge, I'd like to call Larissa Rezende. Larissa, would you please be kind enough to explain to all of our followers and viewers the challenge that you guys are proposing and why is it important for Vale to solve it?
Of course, Guilherme. Hi. Can I start?
Yes, you are free to
Okay.
start.
Hi, everyone.
Whenever
I hope everyone is safe and well. My name is Larissa, and I'm part of Vale Dam's Characterization team. I don't know if everyone is aware of that, but here in Brazil, all of our upstream tailing dams, which is that head embankments of its massive made on the tailings itself, they need to be decharacterized. So since last year, our team has been working to plan and develop the works that will make these structures lose these embankment characteristics. As knowing the tailings is essential to elaborate the decharacterization projects with quality and also to implement the work safely, we need to confirm the current resistance parameters of the materials that constitute these structures. So the big challenge turns around the restriction of access for people that some of these dams present. This is what happens. Some of these valleys structures have very high levels of sorry, they are critical. So we say that they are at emergency level 2 or 3. And why is that? The safety factors, which are defined in the stability analysis and studies of susceptibility to liquefaction, are below the minimum values that were established by our Brazilian legislation. So for this reason, people were evacuated from the self-rescue and secondary safety areas. And these dams are interdicted. No one can step on the tailings. So in that first moment, it's not possible to obtain geotechnical data in the usual way, which would be from the conventional operated equipment in the field. What we need, therefore, is innovative alternatives to investigate and understand these structures. Normally, it's done through drilling process with continuous sampling, CPTU tests. I don't know if everyone is aware of that, if everyone knows what is a CPT test, but it consists of using a hydraulic equipment to push one end of the instrumented cone into the ground through several rods. It continuously measures the resistance needed to penetrate the ground at a constant speed of 2 centimeters per second. And the total force acting on the cone is called the cone resistance and checks the quality of the soil. And the force acting on the rods provides the total friction. Measurements with an electric cone equipped with a friction sleeve provide the resistance to local site friction. And while executing this test, we also do a pore pressure dissipation test and measurement test of seismic wave speed. This investigation is also done by collection of unformed samples with the Shelby or Denison samplers. The Shelby sampler is basically an aluminum tube which is pushed into the ground, and then it extracts a sample of the soil inside it. And the Denison sampler, which is used to form more compact soils, consists in a triple rod equipped with a video cutting shoe. The outer rod is driven into the ground with a rotating drill and water ejection. And the last thing that we need to do in these dams is the installation and maintenance of instrument. This last part, for example, of instrument maintenance is currently being carried out by helicopters. People descend a rope in a controlled manner to check on them. And performing a helicopter flight every time that is necessary to read or maintain an instrument, this is very expensive. So we need an alternative to that. Anyway, the main point is that we need to conduct all of this investigation while ensuring people's safety. In addition, there are other issues that we need to consider. For example, the solution cannot cause significant vibrations in the structure because this can be a trigger for liquefaction. Agility in the implementation is also important because there are deadlines for us to complete this process. And the efficiency of the system itself is also very important. Thank you. We are here to answer any of your questions.
Thank you so much, Larissa. I understand that Rodrigo is also here. If you
Yes.
want to add anything, Rodrigo, to what Larissa just said, please feel free, and I'd really like your contribution. Rodrigo, can you hear us?
Yes, I can. Please repeat.
Yes, if you want to add anything, or if you want to complement anything that Larissa just said to us, please feel free. If moving forward, we had a couple of very interesting questions yesterday. Especially, I'd like to highlight Fernando Dutra. He has been following us for almost all of the webinars, and very active follower, asking very interesting and wholesome questions that can help us to fully understand those challenges. And I'd like to thank him for his presence here and his audience in all of those webinars. It's really interesting that you are so active and interested in MSpot. We thank you for that. So he asked us yesterday, what is the size and weight of the equipments that you use to obtain those geotechnical data?
Usually this equipment has a weight of 9 tons, but we don't have any restrictions about it. I mean, it doesn't matter the size of the equipment and the weight. We just need to investigate these structures in the way that it works. Okay. But
Okay,
normally it's
and
around 9 tons.
nice, yes. So the next question was asked by Milena Fernandes,
Yeah.
uh, and they're asking that what are the types of data of interest? Uh, See, if they're necessarily only direct methods, or indirect measurements would also be interesting.
Yeah, I mean, indirect methods are also interesting for us, but right now we are trying to find a way to do the investigations and obtain the information that we need, the direct methods, but they are also important for us. Okay?
Great. Yeah, I think that this is such a really crucial and key challenge. It's such
Yes.
an important thing to do. It's really nice that we're going to be able to work and find a solution for it inside the program. Thank you
Yes,
so
this is
much for your
very
presence,
relevant
Larissa.
for our company right now. We really need to conduct all of those investigations to complete these decharacterizations projects with safety.
Great. Yeah. Thank you so much,
Okay.
Larissa. Thank you so much.
Do we have
Let's
any
go
other
to our.
question today? No?
I don't think that we have going to have any other questions today, but if they actually arrive from anyone who's watching this on YouTube, not in the live feed, you can redirect your questions to contato at mininghub.com.br, and then we'll forward it to you.
Okay, perfect. Thank you.
Okay. Thank you
Okay.
so much, Larissa, and also thanks, Rodrigo. So going to our next area and our next challenge, we'll be speaking about the technical marketing challenges. And for that today, we have Ali, who is here with us, so that he can explain our first challenge, which is the measurement of the iron oxidate in iron ore sinter with greater agility, which is a really, really interesting challenge as well. Very technical, very science-based. I think this is fascinating. Ali, are you here with us? Could you please start your presentation?
Okay, hello everyone. I hope everybody's well. Okay, my name is Ale. I am a geologist. Okay, and I work at Ferro's Technology Center. Ferro's Technology Center is a research center of Vale. Okay, we are placed in Nova Lima, near Belo Horizonte. Okay, and in this research center, we are dedicated to study the process of our final customers. So First Technology Center is not a mining research center, not a traditional mining research center. Here we are dedicated to the metallurgical clients. We are dedicated to the development of new products. Okay, so the iron ore we study here, it's the final product, the pellet feed, the sinter feed, the lump ore that we sell to the clients. Okay, one of the facilities we have here in Ferrous Technology Center is the sintering machine, the pilot sintering machine. Okay, we have a pilot sinter plant here, and it's to simulate. We are dedicated to simulate the sintering process of our clients with our product. Sure. So Vale doesn't have industrial sintering plants, but all our clients that have blast furnaces buy the sinter feed. Sinter feed, it's the iron ore, the product, the final product, iron ore, that the clients that have blast furnace buy from Vale. And this sinter feed, that is a final particle iron ore, okay, cannot be charred directly on blast furnace. So first, it's necessary one process called by sintering. So this sinter feed, this iron ore, need to be sintered. That is, sintering is a process of agglomerating. So we need to get these fine particles, this iron ore with fine particles, and grow it in an agglomerate. Okay, so we need to do an agglomeration to grow the material. Okay, the sintering process uses iron ore, is the main raw material, but also uses another raw materials. For example, limestones and fuel. The fuel can be coke or anthracite. Okay, so during this process to transform the raw materials, the individual raw materials, in agglomerated that we call by sinter. Sinter is the product of the sintering, okay, of the sintering process. So to produce sinter, we need to use high temperatures. It can reach maybe 1,300 degrees Celsius, okay? And during this process, some chemical reactions can happen inside this machine, inside this process. And one of the things that happens there, it's the formation of the FeO, or the iron oxide. Okay, this kind of phenomenon happens because there are some chemical reactions of reduction, oxidation, and then we have the formation of FeO. Okay, the FeO on sinter is important because it's related to the physical resistance and the metallurgical characteristics of this sinter. So the reducibility, for example, it's related to the amount of FeO that this sinter contains. Okay. And the way that we have to determine the FeO on sinter is to do traditional chemical analysis. Okay, so you need to take the sample, send to the chemical lab, and analyze this by a traditional methodology called wet chemistry. Okay, in this wet chemistry, they do a lot of reactions with acid, some procedures, and it can takes maybe 2 or 3 days to finish and give us the results of the quantification of the amount of FeO. Okay, and nowadays 2 or 3 days it's too much for me in the sintering pilot plant. Okay, why? Because the if the FeO during the process it's too much, it's too high, for example, maybe I need to do an adjustment during the burn, during the test, to reduce this FeO. Okay, but I need to do this on time because the test in the sintering pilot plant just takes 50 minutes, maybe uh, 40, 50 minutes. So I have a test of 50 minutes and I need to wait 2 or 3 days to know the FeO. So what we do nowadays is we don't wait for the FeO. Okay, so nowadays we cannot control the FeO during our tests because I cannot wait for 2 or 3 days to do adjustments. So the challenge, okay, the name of the challenge is measurement of FeO in iron ore sinter with greater agility. What we want here and what we are proposing for you is to find a way, find a solution to have this measurement of FeO faster than 2 or 3 days. Okay. Nowadays, as I said, I cannot control the FeO in this sinter, but I would like to do. So it's very important for us to try to control this FeO. Okay. So if you have an idea, we can use a direct method or indirectly, no problem. Okay. But if you have any ideas and suggestions, please make contact with us and maybe we can do some work together. Okay. Um, all these explanations I give you, it's about sintering process. Okay. But everything that happens in an industrial plant happens too in our pilot plant. The phenomena, the temperatures, the raw materials, everything it's the same. But in the pilot plant, the size is smallest than an industrial plant. Okay, but in terms of characteristics, phenomena, procedures, everything it's similar. Okay, so Guilherme, I think this is it. Do you have any doubts or any questions?
Thank you so much for that, Ali. This is a really interesting challenge, as I believe it's one of our most technical and scientific challenges. And to be able to do this sort of diagnostics in a fast way, I'm sure this will impact. This will create a huge impact in the area and allow you guys to actually perform way better than what you do today. We had a couple of questions yesterday about this challenge, and I'm going to ask them again for you. Um, the first one is from Jorge Fernandes, and he asked yesterday, how do steel mills determine FeO in the sinter that they produce?
Okay. As I mentioned, the main difference between an industrial plant and a pilot plant it's the size, the amount of production. Okay, in an industrial plant we have the sintering machine running 24 hours per day. Okay, it's continuous. In the pilot plant, we have just one test, one test for a run. Okay, so what happens in an industrial plant that they take the sample as exactly as I do here. They take the sample and send to the laboratory. Okay, maybe the time in the industrial plant it's 1 or 2 days. Okay, but they just do the adjustments on the machine in the industrial machine after receive this result. So the difference is in an industrial plant they have 24 hours production and they have more time to do adjustments during a week, for example. In my case, in the pilot plant, I need to do one test, stop, and give the result for the client. So I cannot wait 2 or 3 days. Okay. In the case of the industrial sintering machine, they can do for 1 day, 2 days, 3 days, 4 days. They do the adjustments every day to reach their target on FEO. Okay. But it's not my case. I need to, my test just runs for 50 minutes and I need to do another test after this. So uh, I think that the main difference is the time. They have more time because their process is continuous. In my case, I have just one test in 50 minutes.
Great. I think that's very clear that one of the main issues with this challenge is speed. You need to get this result as fast as possible so you can actually work on with the result on your actual process. And I have a question from myself now. Do you need these diagnostics to run just as accurate and to be just as precise as the one done by the wet chemistry analysis, or could it be could it sacrifice a little bit of the precision for the speed?
Okay, yes, we can sacrifice a little of precision, but we need to understand first if you have an indirect method, for example, for measurement, we need to understand how to correlate to the wet analysis. Okay, so it's more important for us to understand tendencies. So if I have a FEO very high in my test, I need to decrease this FEO. Okay, I can work with tendencies and not exactly with the precision, a precision number, a chirurgical number, okay, with 2 or 3 numbers after the common. It's not necessary, okay? But this method needs to be safe, okay? And we need to establish, we need to test in the beginning of this project, the correlation between the new solution and the traditional way to determine that it's the wet analysis. Okay.
That's correct. It's been great talking to you, Ale. I think we can go and advance to our last challenge of the day. This is the second challenge from the technical marketing area, which is the determination of optimum condition for packaging of mineral particles. The technical responsible for the responsible for this challenge is Flavio. Flavio won't be able to join us today, so he was kind enough to send me all of the information of this challenge so I can actually read that to you guys. So he first started by explaining the whole context of the challenge, and here I will also invite Ali if he wants to complement or give any more details on what was that Flavio sent me. Please feel free to interrupt me at any time and actually add to what he said. Okay. So he first gave me some context on what this challenge is about. So the iron ores currently exploited in the iron quadrangle here in Brazil are of compact itaberate type. So to liberate the highly disseminated iron oxide particles from the gangue, ore comminution is often required, although sometimes the friable nature of the ore minimizes the need for this step. But regardless of that, the production iron ore concentrate is composed of mainly of fine particles of less than 0.15 millimeters used as a pellet feed. So they're really, really small. With a smaller fraction of coarser particles from 15 millimeters to 6.3 millimeters used as sinter feed. So those so the composition of this iron ore concentrate changes, so there's several different kinds of particles. The volumes of fine and ultrafine tailings generated in the process are considerable and often considered an environmental problem, creating difficulties in obtaining environmental licensing of new projects and construction of tailings containment dams. Initiatives are then being taken with the aim of developing viable processes to use such as material as a resource. And traditionally, iron ore pellets are made by agglomerating particles of less than 45 nanometers into 8 to 16 millimeters balls in a rotating disc or drum, which are then hardened by thermal treatment and used as feed to blast furnace or direct reduction modules. Other agglomeration processes can also use those fines particles. The most common industrial processes are sintering, briquetting, and extrusion. Sintering, obviously, as Ali mentioned, the process we were talking about right now. In all these processes, it is essential to connect particles and ensure the best possible packaging. This better packaging will contribute to improving the quality of products. So knowing and obtaining the optimal proportions and being as dense as possible will ensure that this quality is the best that they can achieve. So the challenge will be to develop a tool. This could be a software, a math model, or any other kind of tool that can provide and help them obtain a packaging degree for mineral particles using a previous analysis by existing data. For example, the particle size distribution and shape of those raw materials. As I mentioned, they have a different quantity of particles in very different sizes, and they need to know the optimal way to join them together, to put them together, and create as dense as possible material. So they need to know what is the greater degree of packaging inside that mixture with the differing particle sizes. In addition to that, the solution should treat the available data and indicate the possible packaging degree and how far it would be from an optimal and ideal theoretical condition, and then to indicate the proportions of each raw material and the necessary adjustments to obtain this optimal packaging degree as well. The solution will be used to develop new products and also to control their physical quality. So they actually need to know, this tool needs to inform them how far they are from a totally dense and as dense as possible packaging for those materials which are available. And Ali, I'd like to propose to you to answer some of the questions that were made to Flavio yesterday about this challenge. So the first one was from well, actually it was from Nathan Goulart, and he asked if the shape and the size of the input elements are irregular, or how are they shaped?
Yes, the shape can be irregular. because we are talking about natural raw material. We are talking about iron ore, we are talking about hematites, goethite. So naturally, the shape can be irregular, but we also can have some shape morphologies, and it can be we can be a sort of kinds of shapes. Okay, but answer the question, yes, you can have regular shapes.
Thank you. Yeah, so Fernando, our regular viewer, also asked if it will be necessary to use a scanning electron microscopy to do those tests and see what happens.
Okay, Flavio mentioned in this challenge that they have some properties, for example, size distribution. Okay, so in the case of a scanning electron microscope, I understand it's you can determine maybe the morphology and the chemical by detectors in scanning electron microscope. But you have another properties important, for example, size distribution, maybe porosity, and a lot of properties that maybe you will need some other kinds of techniques. Okay, and in my opinion, in the case of the microscopy, maybe you don't need a scanning electron microscope. Maybe you can work with a optical microscope. Okay, but okay, scanning electron microscope can be used, sure. Okay, but I think it's not enough.
Understood. So I think that that's it for our challenges today. Those three challenges are really interesting. Really, one is hugely important in terms of the whole of the whole company, and other very interesting technical and science related and very with technical aspects challenges, and those are for me one of the most interesting of the whole program. Thank you so much for your explanations, Ale. Thanks for being here today. I'd also like to thank Flavio for sending us this material. If you feel that there's any other questions that you need to know in order to send us your solution, please feel free to reach us at contato@mininghub.com.br. I will also, at the end of the presentation, show this email to you guys so you can be as informed as possible about how the ways you can contact us. Well, I'd like to end this presentation speaking a little bit about MConnect. And if you do have a solution that does not fit any of the challenges explained here today, or any of the challenges proposed in the MSpot program or the MStart program, please but you do believe that your solution is a viable one and it's an important one for the mining sector, please reach us through MConnect. MConnect is a program in which you do not have to apply a solution to a specific challenge, but you can offer your solution for the whole group of mining companies that form Mining Hub. You can reach MConnect through the Mining Hub website at mininghub.com.br/programas/MConnect. If you do reach us and some of the companies find your solution interesting, you will be asked to perform a pitch and actually connect with some of our mining companies who do possess any interest in the solution you just proposed. So if you do have those any solutions that you feel the mining company can benefit from, don't don't feel free to reach us and connect to us through MConnect. Let's go through our webinar schedule. We're already reaching the halfway point of our webinars. With this one, we are finishing 4. There's 4 more to go. I hope you guys stick to us to the very end and get to know all of the challenges we are proposing in the MSpot program and how to apply at the very end. So today we talked about geotechnics and technical marketing area challenges. You can find the previous webinars in the Mining Hub YouTube channel. So we already talked about railroads challenges. We already talked about the energy challenges, and we already talked about the specifics from the call of applications, which was our first webinar. So and about this first one, I'd like to highlight that our deadline for applications is on August 9. So please be aware of that date. Our next webinars are on the upcoming weeks. Our next one, we will talk about the navigation area challenges. After that is the pelletizing area challenges. We'll do a last webinar with this format, with this goal of explaining all the challenges that are being proposed on the ports area. So all of those dates are here. Remember, always on Tuesday and always on Portuguese. On Tuesdays in Portuguese at 2 p.m. and on Wednesdays at 2 p.m. as well, every day, every single day in Brazilian time, in Brazil time, so 2 p.m. here. We are conducting those webinars to talk about all the challenges. And in the final one, in our last week for applications on August 4 and 5, we're going to talk about an application walkthrough detailing every single question that you have to answer in order to complete your application. We hope to see you all during our next webinars. If you have any doubts on the call for applications, please, as I said and I mentioned earlier, please feel free to reach us at contato@mininghub.com.br. Please visit us at our website at mininghub.com.br and through our social media networks at Facebook, at Instagram, LinkedIn, TikTok, and here at YouTube. Just look for Mining Hub in LinkedIn, TikTok, and YouTube, and Hub da Mineração in Facebook and Instagram. There you'll be able to find all the details on the programs, all the details on MSpot, and any other events that we're conducting. You will be able to find details on every other program. For instance, we're conducting the MStart Bootcamp this week. It's been really fun to get to know all of the startups that are going to propose solutions for the shared challenges of the mining companies. And we hope that this will be the case with MSpot in a couple of months from now. So here I'll end this webinar saying thank you. Thanks for being with us today. We hope to see you again next week, and we hope to receive your applications for MSpot and that your solution is able to actually reach the mining sector and impact it as best as it can. See you next week. Hope you're all safe and sound, and until then, goodbye.